My name's Christine Mayer. I'm a researcher at the University of Toledo's Lake Erie Center. I've been researching zebra mussels and their relatives, the quagga mussels, for the past 15 years. Zebra and quagga mussels, Dreissena altogether, have a big influence on lakes. They cause a lot of change. They change the bottom. They take what was smooth substrate, and they make it bumpy. Their clusters are on the bottom, so they really change the structure. Even though Lake Erie, or at least our end, the western basin of Lake Erie, is still a turbid system, they do clear the water a lot. So they're doing a lot of change both in the water column and on the bottom. One of the things that has been shown in a lot of places is that they affect not only plankton, because they filter that and they do consume plankton, is that because they change the light environment, people think that Dreissena are at least partially responsible for blooms to sort of nuisance level blooms of benthic or bottom dwelling algae. So for example, we have here a cyanobacteria or a blue-green algae that's blooming on the bottom, and the water clarity can be a factor in that. So they probably affect things that grow on the bottom, algae that's growing on the bottom, as much as they affect what's up in the water column. Certainly there are other things that promote blue-green blooms. We put a lot of nutrients, especially into this ecosystem. Lake Erie, our end here in the western side of the lake, is a very high nutrient input system. So we can't blame the zebra mussels exclusively, but they likely contribute to that. Quagga mussels are now, at least here, the most common species that we see of the two Dreissena. And quagga mussels can inhabit soft substrate. So silty or mucky areas, whereas the zebra mussels were only found on hard substrates. So they needed something firm to attach to, whereas the quagga mussels can actually spread out over areas. So they can colonize areas that were not colonized by zebra mussels. So they can have an impact that adds on to what was already seen from zebra mussels. For Lake Erie, I don't think people have made a real direct connection between Dreissena and fish populations. Like I said, Lake Erie, the western basin of Lake Erie is a very productive area. So, and it's always been one of the most productive areas. It's one of the most productive, production from Lake Erie is about the same as all of the rest of the Great Lakes together. So I don't think for the western basin people have really connected up Dreissena with impacts on the fish populations, but that has happened in some of the more nutrient poor areas of the Great Lakes. Lake Erie has three basins: eastern basin, which is deeper and colder and more nutrient poor. The central basin is shallow. The western basin is the most shallow area. So in the central basin has recently had problems that include going anoxic or very low oxygen levels on the bottom. It's shallower than the eastern basin, but just deep enough to get stratification, where you get warmer water on the top and cooler water on the bottom being separated by a density differential, and they don't mix up. But it's not very deep, so that bottom layer is actually very like a thin lens at the bottom, and the oxygen can get used up in that layer. Out here in the western basin, it's very shallow, no more than about 30 feet maximum, and we get a lot of wind in this region, so there's a lot of mixing. It does not permanently stratify like a lot of lakes do. Fisheries in Lake Erie, and at least in Ohio, there is some commercial fishing. It's fairly limited. It's small compared to the recreational fishery. So Western Basin has a very active recreational fishery. Most people targeting walleye and perch in this region. In near shore, the people would be fishing for bass and more panfish type things, but very, very popular and important recreational fishery in this end of the lake. There's two different kinds of blue-green algae that we get in the western basin. One is a water column algae called microcystis. People have connected microcystis blooms to Dreissena because they don't prefer to eat them, so they kind of eat the competitors of the microcystis. That forms a thick green scum on top of the water, so it's very it's very unaesthetic. It's not nice to look at. It can start to smell bad. Some strains of microcystis are toxic, so there's concerns for, if especially pets consuming water. The other blue-green algae that we've had here recently is called Lingbia, that grows on the bottom. So that can be affected by Dreissena pulling nutrients down to the bottom, and by their, doing some clearing of the water column. Lingbia on the bottom will accumulate throughout the season. So if you went out in the lake right now and used a dredge or something, you wouldn't find much at all. By August, there are places where you will find a fair carpet of it on the bottom. Then later on in the fall, what has happened is that washes up on shore, and can get meter deep accumulations of it in some places, depending on how the wind's blowing. So it's very unaesthetic, and homeowners and people that use the shoreline really don't like it. Lingbia has been known to exist in the lake for many years. It only started becoming a problem nuisance level in 2006 was the first year. So and that is definitely contributed to by the high nutrient inputs to the western basin of Lake Erie. There's two sources of nutrients to the bottom of western Lake Erie. In general, nutrients are coming into the system through the Maumee River and other tributaries, draining agricultural or urban land that we're putting fertilizer on the ground that's ending up in the lake. Once that gets into the water column, some of that is locally transferred by the Dreissena. In the Great Lakes in general, there's a concept called the nearshore shunt, which just describes how Dreissena pull nutrients to the nearshore region where they're more abundant. In the western basin, the whole basin is really considered near shore. So they're sort of keeping nutrients in the system and keeping them closer to the bottom, and more available to algae growing on the bottom. Otherwise, a lot of that water, those nutrients would probably flow through the system. Oneida Lake is not an oligotrophic lake. It is considered eutrophic. It's always been considered naturally eutrophic. In the early 50s, 60s, 70s, prior to the Clean Water Act, is quite eutrophied by inputs from surrounding towns and industry that put a lot of additional nutrients into the lake. So it was eutrophic, and then we eutrophied it even more. Oneida Lake the water has cleared dramatically and noticeably since Dreissena were found in the lake in 1992, I believe. So 92 or 93. And it's a very different system now since that has occurred. Because it's such a productive system, at least the research that was done come out in the early 2000s, didn't show a change in plankton productivity. So, but it's a very, very productive system, so it's probably not typical of the Great Lakes region in general. Dreissena have a wide-ranging impact on different parts of the ecosystem because they change habitat. Animals or plants that change habitat, ecologists call them ecosystem engineers. That means that they physically modify habitat. Sort of a classic ecosystem engineer is a beaver. They build a dam and they stop a river and make it a pond. And in many ways, what Dreissena do is just as dramatic because they change the bottom and they change the water column physically. So they're clearing out plankton. They can clear out some sediment. That's almost like cutting down trees. So you're letting a lot more light hit the bottom and rearranging where nutrients, where light is, and then because they physically restructure the bottom too, that has a large impact on things that live on the bottom. In general, Dreissena mussels reduce turbidity because they're filter feeders. So they have a little siphon that's essentially a vacuum tube, and they pull in water and whatever's in the water. They filter those particles out, whatever they are, whether they're dirt or phytoplankton. If it's phytoplankton and it's something that they prefer to eat, they'll pull that out and digest it. Everything else kind of gets shunted and kind of packaged up and put on the bottom. So they redistribute particles from the water column to the bottom, whether that's sediment or phytoplankton. Here, someplace like the western basin of Lake Erie, where we have the Maumee River, is pretty much a constant conveyor belt of sediment. So that supply is always being renewed. So even though they do remove some from the water column, our water here is still very turbid. They don't remove any of that sediment from the system, though. It's still on the bottom, And here in our shallow waters, it's often just resuspended. It's pushed up by the wind again. Western Lake Erie is very productive and very shallow and very turbid, much more so than the other areas of the Great Lakes. Places where people have seen negative impacts of Dreissena on the fishery. We've probably seen less negative impact here because of the ability to compensate with a great deal of natural productivity. Because Dreissena are ecosystem engineers, they physically change the habitat. The changes that they cause are not going away. They have caused, structural, physical changes in the lake bottom and water column where nutrients are in the system. So their changes are profound and likely to last a long time because of that physical change component. Because Dreissena are ecosystem engineers, meaning that they physically modify habitat, they have profound changes, they affect many different components of the ecosystem, and that change is likely to be permanent. So the changes that we see today are not going away, and they affect everything in the lake.